Welcome everybody. This is actually 12.5, not 13.5, the fundamental theorem of calculus. So what we're going to learn is more of an evaluation theorem for integrals. So what you see there for theorem 1, if f is a continuous function on a closed interval ab, and f, capital F, is any antiderivative of f, then it goes the integral from a to b of f of x dx will equal the antiderivative, which will be evaluated from a to b, which is written as f of b minus f of a. So we learned how to find antiderivatives last time. So today we're going to find antiderivatives again, but we are going to evaluate them using part of the fundamental theorem of calculus above. Like I said, that's more of an evaluation theorem, but it's still part of the fundamental theorem of calculus. Okay, rules 1 through 6 or formulas 1 through 6 still apply. Those are the same formulas we learned last time. So let's go ahead and try it out. And I'm filming this way so I can show you how to type it in your calculator. So I know there's a little bit of lag, but just bear with me. So I may switch back once we get the hang of it. I say we like you're actually here. Ha. Okay. All right. Okay, let me see. So first up is evaluate the integrals. So we'll start with number 1. So 4 is a constant. So the antiderivative of 4 is going to become, let me get closer. There you go. So the antiderivative of 4 is going to be 4x. Now, normally we would say plus c. But if you see the formula above, there are no constants of integration. There is no c. So when we are using evaluation theorem for the fundamental theorem of calculus, we only want the antiderivative, so 4x. So what we're going to do next is evaluate it on that interval from 0 to 10. Evaluate it on that interval from 0 to 10. So it's always top interval minus bottom interval. So this becomes 4 times 10 minus 4 times 0. Which means that the integral from 0 to 10 of 4 dx is 40. Okay, so now to explain what you just found. So integrals were created to find the area underneath a given curve or line. So this is what integrals and antiderivatives were made for, to find area underneath a curve, okay? Derivatives were meant to find slope and rates of change. Antiderivatives are meant to find area. So if I just drew what we just found here, I want to look at the original function, which is going to be 4. So the original function is y equals 4. Well, y equals 4 is what type of line? Y equals 4 is a horizontal line. So y equals 4, there's 4. So here's y equals 4. It's a horizontal line. But what this antiderivative wanted was to evaluate it from 0 to 10. So we evaluate it from 0 to 10. So this is where we want to evaluate it on. Okay, well, since we're evaluating y equals 4 on the interval 0 to 10, what we want to know is what is the area beneath this line? What is the area beneath this line on that given interval? Well, look at the shape it makes. That's the shape of a rectangle, where the width or the length is 10 and the width is 4. Well, how do you find the area of a rectangle? Area is given by length times width. So area is given by 10 times 4, which gives us 40. And is that the answer we have over there on the left? Yes, that is it. Not bad, right? Okay, so that's all we're doing. Evaluation theorem of the fundamental theorem of calculus allows us to find the area underneath a given line or a given curve on a graph. That's it. That's all we're finding. Okay, so that puts some sense to what we're actually finding here. So, all right. I'll leave that up. Sure. That's just an explanation of what's going on here. All right. And the reason I said I have the calculator up is because I'm going to help you. I'm just going to help you. That's it. I'm going to help you using your calculator. So we're going to start with a TI-30. But if this is only if you have the chromed out edition, which I think is the TI-30X. Let me see. Yes. So you need the chromed out black edition of this calculator. And if you do, well, your life's about to get really easy because watch this. I'm going to hit second and I'm going to hit this little E to the box, 10 to the box button. And look what prints up. Oh my goodness, right? So I'm going to type in 0. I'm going to type in 10 because that was the interval given for the integral. And then I'm going to type in the function f of x, which is 4. Now, watch the magic happen. Hit enter. Oh, it's done. That's it. That's all you have to do to check your work, of course. But it definitely makes the calculation a lot faster. Okay, because it is still smart to work the integral and the antiderivative out by hand. And once we do it by hand, then you can go to your calculator and get the output immediately. Okay, so that's on the chromed out edition of the calculator. Now let's say you have the TI-84. Well, life is good again because let's go to, let me clear all that. I'm going to go to math and then I'm going to scroll down to F and integrate. So math and number 9, right? So math number 9, I'm going to hit enter and watch what magic happens. Oh my goodness. Wow. Right? So we're going to type in that same integral, 0 to 10. And you're going to type in 4. Oh, and this one will want with respect to what? So 4, and we're doing it with respect to x. There you go. And now all you have to do is hit enter, and bam, life is good. Your work is now double checked, okay? All right, well, let's say you didn't have either of those calculators and all you had was or let's say your graphing calculator couldn't do this. So I would go to the y equals. I would type in the antiderivative for x. Hit enter. And then I would do second window. And I would go down, skip, go to independent, go straight to ask. Hit enter. And then hit second graph. There's the XY charts. So I've taught you guys how to go through all this. So all you're going to do now is plug in the intervals into the function. So we start with 10. I type in 10. I get 40. I type in 0. I get 0. And again, 40 minus 0 is 40. So that's another way to do it if you don't have the integral button on your calculator. which means let me go back to the other calculator. So let's say you didn't have all of this. I would go, let's say you had just a regular blue calculator that I love, this one. This one doesn't have that integral button. So what you're gonna have to do is go to your table button, type in the antiderivative for x, hit enter, skip, make sure ask x is on, then go to OK. Then you'll type in the first number of the interval, which is 10. Then you'll type in the second number of the interval, 0. And again, subtract those two numbers. 40 minus 0 gives us 40, which we have over there. So there's multiple ways to make your life easy, but if you have the integral button, go ahead and use it. Why not? Go ahead and use it. Makes your life easy. Okay, let's keep going. Okay. All right. And no, we don't have to draw a graph every time. I drew a graph on the first one to show you what we're actually finding. We are finding the area underneath a given function. Okay. Perfect. Keep going. Now we want the integral of x squared from 0 to 6 dx. So for this one, it will use power rule, where we add the 1. So hopefully we're good at it by now. This becomes x cubed over 3. And you want to evaluate it from 0 to 6. We want to evaluate from 0 to 6, which means that I will get 6 cubed over 3 minus 0 cubed over 3. And 6 cubed is what? 216. Let me see. 6 cubed, you get 216 over 3. Now watch this fun trick. How many times does 3 go into 21? 7 times. How many times does 3 go into 6? Twice. 72 is our answer. And of course, double check our work. I'll do second integral 0 to 6 of x squared. There it is. Hit enter. 72. Look at that. Okay. And one more quick just refresher on what we just found. So we're looking at x squared. So let me see. So x squared looks like this. Well, we wanted to evaluate x squared from 0 to 6, which means that we wanted to find the area underneath this curve. So this is everything we found. So all this area is equal to 72. That's it. That's all we're looking for. So again, I don't have to draw graphs for you don't have to draw graphs for every single one, but I want to explain what's going on. So using the antiderivative finds the area underneath a given curve, given line, given curve, given function. So that's how we're finding. All right. So of course, it might make more sense when I actually start doing word applications, right? So there's that. All right. Who's emailing me? Okay. 3. Let's keep going. All right. 3. So this will be 2 antiderivatives, right? So what we're going to do first is look at 5x. So the 5 will remain on the outside, and the antiderivative of x using power rule will be x squared over 2. Plus, now we look at the antiderivative of 3. The antiderivative of 3 is going to be 3x. Okay, which means now we will evaluate this from 1 to 4. But let's make it look pretty. Okay, so we know that 5 halves becomes 2.5 x squared plus 3x, and we're still going to evaluate this because we haven't done it yet. We're still evaluating this from 1 to 4. Okay, we are now ready. All right, so this will become 2.5 times 4 squared plus 3 times 4 minus, I'm going to put a bracket here for neatness, 2.5 times 1 squared plus 3 times 1. All right, now let's simplify. And this is where the calculator comes in handy, right? So for that left side, I have 2.5 times 4 squared plus 3 times 4. So that gives me 52. So this left side is 52 minus, over here on the right side, 2.5 times 1 squared plus 3. Well, that's 2.5 plus 3. So that's 5.5. Okay, and now 52 minus 5.5, 46.5. There it is. That is the area underneath that curve or function. We'll just say that. Okay, now, of course, calculator work. Let's say you want to check your work. Second antiderivative, 1 to 4 of 5x plus 3. Enter. 46.5. My goodness, so much easier, right? Okay, now once again, let's say you don't have that. Let's say you have to use the table feature. Well, again, if you're using the table feature, you are going to type in the antiderivative, which is right here. Look on the right side real fast. This is what you will type in to the calculator. That's what I'm putting in the table. So I would do y equals 2.5 x squared plus 3x. I will hit enter. Your settings should be the same. If not, make sure it's on Ask X. Hit enter, hit OK. And then I'm going to type in 4, which is the top of the interval. And look what I'm going to get, 52. Then I'm going to type in 1. Look what I'm going to get, 5.5. And all we have to do is do 52 minus 5.5, which is right here for what I have on the right side, 52 minus 5.5, which gives me the 46.5. Okay, excellent. So that's how you do it. And again, before I move on, I'll show the graphing calculator. Y equals again, let's say your graphing calculator doesn't have the integral and you need to use the XY charts. So I'm going to do the same thing. 2.5 x squared plus 3x. Enter. Second window. Your settings should be the same. Once you change them, they're good. They're set for life. But if not, just go down to independent and make sure it is on ask. Hit enter on that. And then you're going to do second graph. And you can clear out numbers here as well. See, I can get rid of all the numbers by hitting delete. So I'm going to type in the top of the interval, 4, 52. I'm going to type in the bottom of the interval, 1, 5.5. 52 minus 5.5, 46.5. So that's how you work it on your calculator. All right. So now you know. Now we can get this process rolling. Let's do it. Okay. Next one is the integral from 0 to 1 of e to the x. Well, guess what the antiderivative of e to the x is? E to the x. And you will evaluate it from 0 to 1. Okay. Which means that we'll get e to the first minus e to the 0th. And this becomes e minus 1, because anything to the 0th power is 1. So you get e minus 1. Okay, but let's say we want to actually get a decimal number out of this. So let's see what our calculator does for us. So I'm going to say second, nope, this one already has it. Oop, clear. E to the first minus 1. And I get 1.718. I'll just do this to 3 decimal places. I get, let me do the squigglies on this one. This one becomes 1.718. There we go. Again, check my work. Second integral 0 to 1 of, and if you need to type in e to the x, there's e and to the x. That's it. 1.718. Golden. Life is good, y'all. Okay. 5 is the integral from 1 to 2 of 1 over x dx. Now remember, the integral or the antiderivative of 1 over x is the natural log of the absolute value of x. So this makes it easy. This means that this becomes the natural log of the absolute value of x evaluated from 1 to 2. That's it. And now plug in those numbers. You get natural log absolute value of 2 minus natural log absolute value of 1. Let's go ahead and type those in our calculator. And I'm going to do squigglies. So I'm going to say natural log, which is here, of 2. Don't worry about the absolute values. Just put natural log of 2. And to 3 decimal places, I get 0.693. And then let's do the natural log of 1. Does anybody know what the natural log of 1 is? No matter what. The natural log of 1 is always 0. So we have our answer. The natural log of 2 is going to be 0.693. Okay. Come on, computer. Catch up. You're doing great. All right. Let's see. Well, you see the answer over there on the left, but I do need this computer to catch up. Come on. There we go. Welcome back. Okay, cool. All right, 6. Let's keep going. All right, number 6, the integral from -2 to 2 of x cubed plus 7x. Okay, so let's look at x cubed first. We're going to find the antiderivative of that, meaning we will use power rule on that. So the antiderivative of x cubed is going to be x to the 4th over 4. That one's done. Plus, now we look at 7x. The 7 will stay outside. And again, we will use power rule on the x. So that is x to the 1st, which means by power rule, that becomes x squared over 2. And you will evaluate it from -2 to 2. Okay. Let's make it look pretty. All right. So I'm going to show you some rewrites really fast. X to the 4th over 4 is the same as 1/4 x to the 4th plus 7/2, which is 3.5 x squared. All right, still evaluating from -2 to 2. And then one more rewrite before we evaluate it, because 1/4 can be rewritten as 0.25 x to the 4th plus 3.5 x squared. Evaluated from -2 to 2. Okay, so here is our evaluation. This becomes 0.25 times 2 to the 4th plus 3.5 times 2 squared minus, put a bracket here to keep everything nice and separated. Come on, computer, catch up. Okay. And then again, 0.25 times -2 to the 4th plus 3.5 times -2 squared, close bracket. Okay, and let me use my table feature. Let's see. I have 0.25 x to the 4th plus 3.5 x squared, enter, no function there, go down to x equals, and I'm going to type in 2, and that gives me 18. So the left side of this becomes 18 minus, if I type in -2, I get 18. Which means 18 minus 18, we get 0. Ooh, how can an area be 0? Questions, questions. Ponder, ponder. Well, you would have to look at the graph to think about it. So that'll come later on. Maybe. Or maybe I'll leave you guessing. Okay, that's it. Okay, check my work, of course. Second integral, -2 to 2 of x cubed plus 7x. Done, done, done. Hit enter. 0. My goodness. There you go. That's how we check our work. Perfect. Keep moving. Number 7, 2x plus 9. So let's do it. 2x. We'll leave the 2 outside, and we're just taking the antiderivative of that x, which will become x squared over 2 by the power rule. Plus the antiderivative of 9, which is 9x. Okay. And now evaluate this from 2 to 5. All right. There we go. Okay. So clean it up a bit. I get that these 2's cancel, and we get x squared plus 9x evaluated from 2 to 5. Okay. So now I'm going to save us some time, and we know how to work it in our calculator. So I'm just going to type in the integral and get our answer. Second integral to 5. That is 2x plus 9. And enter. I get 48. Done deal. So type that in your table, type it in your integral, work through the steps, but now we can sum it up by just moving from this step to the final step using your calculator. So that's how I want you guys to work it. Yes, I showed you your calculator can do it in less than a second, but still work it out by hand. Trust me, you want to do that. Okay, perfect. Let's keep going. Okay, number 8. Let's do it again. So we're going to look at first the antiderivative of 6. The antiderivative of 6 is 6x. Then we're going to look at x cubed. So there's a minus in front, and you're going to use power rule on this. The antiderivative of x cubed becomes x to the 4th over 4. And we will evaluate from 2 to 3. Okay, rewrite. I get 6x minus 0.25 x to the 4th, evaluated from 2 to 3. And like I said, after you've done the antiderivative by hand, go ahead, plug it in your calculator, use your table feature, use your integral feature. Let's get the answer. So I'm just going to go second integral 2 to the 3 of 6 minus x cubed. 6 minus x cubed. There it is. Enter. I get negative 10.25. All right. Now, how can area be negative? First, we had area being 0 and area being negative. My goodness. Like I said, it all depends on the function and the interval that you choose, right? So, crazy to think about. Okay, let's keep moving. These aren't bad anymore, right? All right. Number 9, the integral from 1 to 2 of 2x to the negative 2 minus 3. So here we go. So this 2 will stay up front. And we want the antiderivative of x to the negative 2. So that will use power rule. If you power rule that, you'll get x to the negative 1 over negative 1 minus the antiderivative of 3, which is 3x. Okay, and you are evaluating this from 1 to 2. Okay, so clean this up, and this becomes 2x, not just 2, but negative 2x to the negative 1 minus 3x from 1 to 2. Okay, like I said, once the fun part's over, you can now type this in your calculator to get the exact answer. So clear that. Second integral 1 to the second of 2x to the negative 2 minus 3. And hit enter. Yes. Just making sure we're all good. And we get negative 2. Okay, awesome. Would that be, yeah, perfect. All right, 10. Oh man, we're almost near the end. Look at that, not bad. All right, 10. First, we have to rewrite this because it's in the square root form. So we have to rewrite it as the integral of 1 to 4 of 3x to the 1/2 dx. 3x to the 1/2 dx. All right, which means we are now ready, which means the 3 will wait outside. The 3 will wait outside, and you're going to power rule this one. And when I say power rule, since it's a fraction, I'll help you out. You get x to the 1/2 plus 1 over 1/2 plus 1. Make that 1 over 1. Get a common denominator of 2. Let's go, computer. There you go. X to 1/2 plus 1 over 1/2 plus 1. Make those into common denominators of 2. And I get x to the 3/2 over 3/2. So this is coming back in here. Okay. So we get x to the 3/2 over 3/2 evaluated from 1 to 4. Okay, definitely clean this up. So since I have a fraction in the denominator there, remember this one will flip. Okay, which means I get 3 times 2x to the 3/2 over 3 from 1 to 4. This 3 cancels, that 3 cancels, and you get 2x to the 3/2 from 1 to 4. All right. Now, let's do the quick calculation. And I'll say clear second integral 1 to 4 of 3 second square root x. There we go. 3 square root x dx. Hit enter, and we'll get 14. Perfect. So plug in for, what's that, 64, and then that's 8, so that's 16 minus 2, yeah, that's 14. Okay, we are good to go. Let's keep going. I think we made it to the last one, peoples. Yeehaw. Okay. So, a company manufactures mountain bikes. The research development produced the marginal cost function, C prime of x equals 500 minus x over 3. And they're giving us the interval from 0 to 900, or the domain from 0 to 900. C prime is in dollars, and x is the number of bikes produced per month. Compute the increase in cost going from a production level of 300 bikes per month to 900 bikes per month. Set up a definite integral and evaluate it. Okay. So we want to do an integral of the average or the marginal cost function. So here's our setup. We will have the integral from 300 to 900 bikes of C prime of x dx. C prime of x dx. Okay. Where do we have C prime of x? Yes, it's given by the above. So let's plug that in. So this becomes the integral from 300 to 900 of parentheses 500 minus x over 3 dx. All right, let the computer play catch up. And I apologize for doing this way, but I want to show the calculator. I want to have the split screen with the calculator, because if not, I would constantly have to be going between this screen, that screen, this screen, that screen, and I just rather have them both up at the same time. The only downfall is the computer trying to catch up with my tablet, or whichever is the problem. Let's go, let's go, let's go. There we go. 500 minus x over 3 dx. I wonder if I can change like sync to happen instantly. I don't know. I'll look into that. Okay, so let's continue. I'm gonna make it look a little nicer so you can actually see the integral a little clearer. So this is 500 minus, and the only one I'm rewriting is the x over 3. That's the only one I am rewriting. Because all I'm going to rewrite it as is 1/3 x dx. That's it. 1/3 x dx. Which means we are now ready for the antiderivative. And we'll start with 500. The antiderivative of 500 is 500x. So we take care of that. Minus that 1/3 now stays out front. And now we just want the antiderivative of x. And that will be using power rule. So that will become x squared over 2. X squared over 2. and we will evaluate from 300 to 900. But let's make it look pretty first. So 500x minus 1/6 x squared evaluated from 300 to 900. All right. Now, all we have to do is type it in our calculator. So, clear second integral 300 to 900 of 500x minus, I'm gonna hit my fraction button here. Oh, no. Don't make that mistake. Not 500x, just 500 minus 1/3 x. Remember to type in the original function. Do not type in the antiderivative in here, or we'll get it wrong. 500 minus 1/3 x, and we'll get 180,000. 180,000. All right. So this is telling us that if we increase production from 300 bikes to 900 bikes per month, this means that cost is going to increase. So cost increases. Of course, I mean, it makes sense. If you make more product, cost is going to increase. But let's hope we actually have a revenue, right, to beat it out. Okay, that's it. That is evaluation theorem for the fundamental theorem of calculus. So we know how to do antiderivatives already, but now we are just evaluating those antiderivatives. All right, that is it, y'all. Okay. And stop.